In this video, I'm going to be recording solutions for Algebra 2 Quiz 5.1, which is all about exponent rules. So the first three are about powers of numbers. And I think the rule that we need to remember here is the rule about negative exponents. So that's x to the negative a power equals 1 over x to the a. So 2 to the negative 1 is going to be 1 over 2 to the first power, which is going to be 1/2. And then also something to the 0 power is going to equal 1. So 3 to the 0 equals 1. A 4 to the negative 2, that's going to be 1 over 4 to the second power, and that would be 1 over 16. The next two are getting at the product of powers and power of powers. So we're just going to simplify these expressions. Okay, so I think the thing we would need to remember for this one is that x to the a times x to the b is going to equal x to the a plus b. So this is going to be x to the 2 plus 5, which is going to be x to the 7. Then over here, the power of a power rule is that if we take x to the a to the b power, that's where we're going to multiply the exponents. So this is going to be x to the 2 times 5, which is x to the 10. The quotient of powers rule. So if we have x to the a divided by x to the b, that's equal to x to the a minus b. You can look at the x to the b in the denominator as an x to the negative b and look at it as multiplication of two things with same base and different exponent, then we'd add them and get a minus b. Either way, that's where we subtract exponents. So I'm going to group the numbers and then group the variables. Okay, and 12 divided by 9, okay, those both have a factor of 3 in them. So I'm going to write 12 as 4 times 3, 9 as 3 times 3. And then, I'll just think about this 3 over 3 here as a 1. And so this is going to be equal to 4/3 of x. Then this next one, we'll deal with the quotient. I guess it doesn't even, that's not even related. No, we're not going to divide two things with the same base. So we're just going to apply the negative 2 power to everything. Okay, so we'll say this is going to equal, let's run this over here, 2 to the negative 2 power times x squared to the negative 2 power divided by 3 to the negative 2 times y cubed to the negative 2. Okay. And then we're going to use power of power again like we did up above. And we're going to say, okay, well, 2 to the negative 2, well, if we're already on a fraction, we could send that to the denominator and make that a positive 2 power. And do the same with that 3 to the negative 2 in the denominator. It could become a 3 to the positive 2 in the numerator. But then I might just, multiply the exponents, y to the negative 6 and x to the negative 4. And then I guess I can send those to the opposite side. So I'd have 3 to the 2, y to the 6, divided by 2 to the 2, x to the 4. And then I know what 3 to the 2 is, and what 2 to the 2 is. But after that, there's nothing more I can do because I can't divide y to the 6 by x to the 4. I need to have the same base to divide those things. Right, this next one, okay, this is where we're going to set up a little algebra equation and solve it or something like that. This one doesn't look like it would be too hard. Okay, if we've got the same base and different exponents and we're dividing them, subtract the exponents. So that's x to the 2 minus 5 equals x to the k. So that's x to the negative 3 equals x to the k. And I think it's pretty self-evident at this point that that means that k needs to equal negative 3. This next one, that was the one I was thinking about, where you had to maybe set up a system or something. So x to the 3a times x to the 2b equals x to the 11. Well, we know that that's x to the 3a plus 2b, because we're multiplying those things. And x to the a divided by, that's equal to x to the 11. And then we also know that x to the a divided by x to the b is x to the a minus b. Okay. And what we can do is we can say, okay, if these various powers of x are equal, then they need to have the same exponent. So that means to me that 3a plus 2b equals 11 and a minus b equals 2. And now we're just going to be able to solve this system probably with elimination. Yeah, I'm thinking I'm going to take this equation right here in blue and multiply it by 2. I'll have 2a minus 2b equals 4. And I'll kind of, add those all together. I'll get 5a equaling 15, and that would tell me that a equals 3. And a minus b equals 2, so that would mean b equals 1. Okay. And you can look at that and kind of verify. Yeah, that works for both of them. Yeah. So a is 3 and b is 1. Alright, simplify and write the expression with no negative exponents. Alright. So I'm thinking I'm going to kind of split off the numbers from the x's from the y's. And 2/6, that's 1/3. Probably not going to need to 1. Put this all together in one fraction. X squared divided by x is just 1 power of x on top. 2 minus 1, look at it like x to the first on bottom. And then if I had y to the first on top divided by y to the negative 1, that's going to be y times y, or you could subtract the powers again and say that's going to be y to the 2. Okay. Probably don't need that much fraction. Maybe like that. And then the next one would be pretty much the same. So 20 divided by 5, that's 4 on top. X to the 3 minus negative 3 would be positive 6. Y to the negative 2 minus 9 would be y to the negative 11, but it said no negative exponents, so we can do that. Just turn it into a fraction. And there we go, we're good. Oh, and then there's one more here. Oh no, 2 more. I can squeeze them both onto the screen, yeah. If x to the 5a times x to the 6 equals x to the 8, what's the value of k? Okay, well, we're multiplying these two things, we're going to add their exponents. Whoops, I didn't actually add the exponents. Okay, well, I can say that's 5a plus 6. And then I'll say, okay, if these two things are equal, then they have the same base, and it's because their exponents have to be equal. So I'll say 5a plus 6 equals 8. And I'll just solve for this the way we have been this whole year. I'll get a is 2/5. And then if x to the 2 to the k, so that would be x to the 2 times k, that's where we would multiply, equals 1 over x to the 12. Okay, that's x to the negative 12. What's the value of k? Right, so these are the two things that would need to be equal. 2k equals negative 12, and that would mean that k needs to equal negative 6. And that's all for Form A. Alright, Form B, let's go. So I'm going to go a little faster through these, I think. So x to the 3 to the k power, that's where we would multiply 3 and k. So x to the 3 times k equals x to the 12. That would mean that 3k needs to equal 12, and k would be equal to 4, right? Because if two exponential expressions have the same base and they're equal, then they have to have the same they have to have the same exponents. Okay, the second one would be x to the 3a times x to the 2. That would be a situation where we would add. So x to the 3a plus 2 is going to equal x to the negative 10th power. Okay. Because 1 over x to the 10, that's the same as x to the negative 10. And then I'll equate the exponents. 3a plus 2 equals negative 10. And then I'll just solve for this, like I said, like we have been doing the whole year. So 3a is negative 12, and a is negative 4. Oh, well, yeah. We're solving for the value of a. Alright. Simplify and write the expression without any negative exponents. Alright, we're going to do this. So we're going to split off the numbers from the x's from the y's. I think it's probably the most fail-safe way to do it. 9/3 times x to the 1 over x to the negative 4 times y to the 4 over y to the 3. Okay, and 9 divided by 3 is 3. X to the 1 minus negative 4, y to the 4 minus 3. That's going to be 3x to the 5, y to the first. And then this next one, we'll split off the numbers from the x's from the y's. And 5 over 10, that's the same as 1 over 2. This would be x to the negative 2 minus 8 times y to the 3 minus negative 3. So that would be 1/2 y to the negative 10, wait, no, x to the negative 10, y to the positive 6. But it said no negative exponents, so we'll see that's 1 y to the 6th over 2x to the 10. And that has no negative exponents. Alright, number 4, if x to the 3a, x to the 2b, okay, that's where we would add the exponents. That's equal to x to the 3. Okay, well, I know that's telling me 3a plus 2b, that needs to equal 3. And then over here, x to the a divided by x to the b, that would be x to the a minus b. That's equal to x to the 11. That would mean that a minus b need to equal 11. Right, I'm thinking, kind of like on the other version of this quiz, I'm going to multiply the equation in pink by 2 to set up for elimination. So it would be 2a minus 2b equals 22. I'll add these together. I'll get 5a equals 25. That would tell me that a would need to equal 5. And then a minus b equals 11. So I feel like b would need to equal negative 6. So I'm going to go back in and kind of, I wouldn't necessarily expect you to do this on paper, but maybe you could do this mentally. We could say x to the 3a, x to the 2b, yeah, that's x to the 3, and x to the a over x to the b is x to the 11. Yeah, that works. Okay, and that didn't take too long. And it's worth a check. All right, these next ones are going to be simplify the number where it's got a negative or a 0 exponent. We can do this. So 5 to the negative 2, we turn it into a fraction and make the exponent positive. 1 over 5 to the 2, that's 1 over 25. Okay, 4 to the 0 is 1. And you could just remember anything to the 0 is 1, or you could look at it as, okay, it's like 4 to the 5 divided by 4 to the 5, or, that would be a situation where we would subtract exponents and get 0, right? And anything divided by itself is going to be 1. Okay. And 3 to the negative 1, that's 1 over 3 to the first, which is 1/3. Oh, whoops, couldn't see that, but no, know that you needed to. All right, here, it looks like we're ending with some easier ones. So simplify the expression, x to the 3 times, or to the 4th power, that would be 4 of these, so we would add them together and we get x to the 12. That's why we multiply the exponents in that scenario. And then x to the 3 times x to the 4, that would be x to the 3 plus 4, and that's going to be x to the 7. So, down. All right. We'll simplify the expression. There we go. So split out the numbers from the variables. Okay. And 10 divided by 4, those are both even numbers, so I can say that's 2 times 5 divided by 2 times 2. And then kind of look at this as 1, and so 1 times 5 halves is 5 halves. And x to the 5 divided by x to the 6 would be x to the 5 minus 6, which would be 5 halves x to the negative 1. And I mean, it didn't say simplify with no negative exponent, so you could stop there, or you could put it in the denominator. You could say that's 5 halves times 1 over x, which would be 5 times 1 divided by 2 times x. And this last one, I think, nope, there's another one. All right, so this one over here, I'm just going to scroll over. Okay, I'm going to hit everything with that negative 2 power. So 5 to the negative 2, y cubed to the negative 2 divided by 4 to the negative 2, x to the 4 to the negative 2. Okay. You could do that, or maybe I'll do this a different way also. And I'll say, okay, the negative would take this fraction and flip it, right? And then we'd still be left with the positive 2 power. And then you could say that I would just square everything. 4 squared, x to the 4 squared, divided by 5 squared, y to the 3 squared. I don't like that better, maybe, but it's alright. If I was to say, at least with the numbers, 5 to the negative 2 would be 5 to the 2 in the denominator, 4 to the negative 2 in the denominator is the same as 4 to the positive 2 in the numerator. That would be y to the negative 6, x to the negative 8, and we know that those negative exponents cause those variables to kind of just like switch sides on the fraction. So I'd have 16x to the 8 over 25y to the 6, which is what I got the other way. Okay, it doesn't really matter, it's just how are you thinking about it. And then the last problem is x to the 4 divided by x to the 9. Okay, that's going to be x to the 4 minus 9 is equal to x to the k. And 4 minus 9 is negative 5. And then it's looking to me like k is going to equal negative 5. And that's all for this quiz.